Hello guys, welcome to day 2 of learning about Earth's atmosphere. Today we are going to talk about atmospheric pressure and temperature. Let's see. So first we'll talk about pressure. As altitude increases, air pressure decreases. Altitude, if you remember, is the distance from sea level. Now, if I was living in a second floor apartment, the altitude of my apartment would be how far away it is from the sea level, right? So here we're going to learn about how as altitude changes, air pressure can change or it can change. So now if you remember, if you've ever been on an airplane, you'll probably remember your ears popping, especially when the airplane is taking off or trying to land, right? And this normally occurs because the differences in air pressure as you move from one place to another, right? So that's what we're going to learn about today. And if you remember from yesterday, you would remember that the atmosphere is kind of like a blanket around the earth, right? And the reason why it stays around the earth is because of the gravity of the earth. If we didn't have gravity, the air particles would float away into space, because of which we would no longer have atmosphere. So it is held down by the gravity. And the gravity of the earth acts to move the gas molecules in the atmosphere towards the earth's center. So if you remember from your previous lessons, you would know that at the surface, the gravity is where okay, let me rephrase that. So at the center of the Earth, the gravity is the strongest, right? So if you think about it, the Earth's surface is where you would feel the most of the Earth's gravity, because of which the Earth's surface is also where you would find a lot of gas molecules, right? And the force of gravity is balanced by air pressure. Air pressure is nothing but literally the measure of the force with which air molecules push on a surface. Now, if you are holding your hand down and pushing on your table, right? That is the pressure that you create, right? That is the force with which you are pushing on the surface of the table. That is exactly what we are talking about here. Now, air pressure is literally the force with which air molecules are pushing down on a surface. Obviously, like we've already talked about, air pressure is the strongest at the Earth's surface because there is more air above you. So when there's more pressure coming from above, and there's a lot of particles at the bottom as well, the pressure will be strongest at the Earth's surface. As you move away from the Earth's surface, there'll be fewer and fewer air molecules above you, because of which there will be a lower rate of air pressure. Now, if there are fewer air molecules above you, obviously they would not be able to exert as much pressure compared to the areas where there are more molecules, right? This is why there is a lower rate of air pressure. And so as altitude increases, so as you go higher and higher above the sea level, there are lower particles, because of which the air pressure decreases constantly, right? And obviously the air pressure and gravity exist in a near state of equilibrium, which means balance, right? Now let's look at this diagram real quick. Now here it says with altitude, air density decreases. If you remember density, it means how much the amount of particles exist in a given area, right? That's what we're talking about here in this specific diagram. So now the air density decreases with altitude. Now let's look at these two columns of air, right? Now if you see, the most amount of air molecules are present here when compared to over the top, right? So this area is less dense when compared to these areas, right? And that's because there are more molecules here. So as you go higher up, the density of the air column also decreases, right? Similarly, if you were going to think about it, the air pressure in this area would also be the highest because there are more molecules that are pushing to this area, right? So if you were to think about it, on the ground, more molecules are pushing to the surface. Like we have this entire column that is pushing or putting force to this surface. So obviously the air pressure is going to be higher here. But when you look at here, same is the case. But when you were to compare between these two areas, Mount Everest has fewer air molecules above it compared to the ground, right? So the air pressure on this area versus this area has a considerable difference. Since there are more molecules pushing to this surface, it's going to be very high. But since there are fewer molecules compared to the ground that is pushing towards the top of the Mount Everest, the air pressure here is obviously going to be very low. Now let's look at atmospheric composition after that affects air temperature. Now, as altitude increases, air temperature changes. I'm pretty sure you've heard how when altitude increases, there is lower air temperature. And this is actually why, snow also like does not melt very often at the mountaintops and you can still see them, right? This is because there is lower air temperature as you go higher up, and because of which they have a harder time melting the snows, right? So now the temperature that you see, the difference that you see in temperature is actually because of the way energy is absorbed. So when the solar energy is absorbed, it moves through the atmosphere, right? And it's warmer near the surface because there are a higher percentage of gases or particles that absorb solar energy compared to the top of Mount Everest, for example, where there are a lesser amount of gases and lesser air particles that can absorb these gases. So the more gases there are, the more air molecules there are, the more they can retain solar energy and the more warmer it can be compared to other areas. I hope that helps. Again, if you have any questions, please go ahead and email me and follow up with me, and we will talk about it in more detail. Have a great day, guys.